taking an apple and then made a computational model. I used the momentum principle, setting the net force equal to 0, which gave a pretty good prediction of the movement I observed. I uploaded the video to Tracker and set the time period I would analyze by moving these black arrows right here. This is my video. I set the origin at the center of the apple in the very first frame, right here. For the what if question, if I had chosen a different point for the origin, such as on my foot before I kicked the apple, the position would have changed at each time, but the change in distance would stay the same, and therefore the velocity would stay the same. I chose to have the apple moving in the positive x direction, the plus to x direction, and move the axis to fit the path of the apple, like this. I then took the center of the apple as the average position, and as it moved, I found it at different times. I set the diameter of the apple with the calibration stick as 0.06 meters. The time between each frame was about 0.04 seconds, and the total time was 0.25 seconds. I then began to make my model. For my model, there are some things I need to know. I plugged in the mass of the apple, which was 0.15 kilograms. The initial position was from the first frame, which was at the origin, which was about the origin right here. So I put 0 as the position. For the velocity, I found the initial velocity by dividing the total distance, right here, by the total time. I found the distance by looking at my tracker information, and I did the final position minus the initial position, right here, divided by the total time, which is 0.25 seconds. And I got 0.508 as my initial velocity. I plugged that in right here as my initial velocity. I predicted for time less than 0.25 seconds and applied Newton's second law, which says the change in velocity is equal to the net force divided by the mass times the change in time. The final velocity will be equal to the initial velocity of 0.508, which means the force will have to be equal to 0. And that causes the change in time to be 0, making the velocities both constant. I set that in the model, making the force equal to 0, right here. And I use this to predict the model. For the what does it mean question, it is not possible to say how many pushes and pulls are added together to give 0 net force, because the net force is assumed to be 0, since there is a constant velocity. As I run this module, you can see the ball starts at the origin and runs for 0.25 seconds in the positive x direction. I then took this data right here, and I compared it to the tracker information. So as my x-axis is the time, y is the position, the red is the tracker position I got, and the blue is the computational model position I got. I compared the two, and they look pretty similar. If I had increased more time and position points, I probably would have gotten an even more closer comparison. As you can see, both sets of data matched up pretty well, confirming the accuracy of Newton's second law and of objects with constant velocity.